Welcome to week 7 of Advanced R, Geography 473, 673, University of Delaware. This week is about creating functions and then presenting code. So we're going to click on the week 7 link. And so far, we've only really been using functions that are pre-built for us. And that is because there's some wonderful people out there who have created packages with functions that we don't need to know exactly the ins and outs of to be able to use. For example, there's a function called ncopen that opens a netcdf file for us. There's a function called sequence that creates a sequence of numbers for us. All of these are functions that other people have built. However, it's also possible to build your own functions. So let's demonstrate that here. So right now, I'm just going to copy over some code right here. And that code is just going to look like this. We have an arg1, which is equal to 1, arg2, 5, and we're going to create a sequence of those numbers, 1 to 5. So this is what it looks like. This is what my sequence looks like, 1, 2, 3, 4, 5. I'm going to square my seq. Okay, so I'm going to square all of those values, and then I'm going to print those out. So now we have 1, 4, 9, 16, 25. So this code is pretty straightforward. We just wanted to create a sequence of numbers and then square each of those numbers. But let's assume that we want to run this over multiple sets of arguments. Let's say that we have, an entire list of argument 1s and an entire list of argument 2s, and we want to create some sort of streamlined way to make that happen. The way to do that would be this. Creating a function called seq squared. So this is what's going on. We are saying seq squared equals function. And within this function is going to be called seq squared, and it's going to take the arguments arg1 and arg2. Then it's going to be set up exactly the same way for loops are in R. So in between two curly brackets, this is what the function is doing. It's creating a sequence of arg1 to arg2. It's squaring that, just like we did up here. And then it is returning, the function is returning to us my seq squared. So it's the same exact thing. If we already have arg1 and arg2 set, we can actually call this now seq squared, and we can say arg1 equals our arg1 and arg2 equals our arg2, which we already have defined up here. Run this function, and it spits out exactly what we wanted. We can then use this for 5 and 10. So we see how quickly we can streamline these functions right here. And we can create our own functions that make coding fast and easy for us down the line. And we can actually see this over here, that our function that we created, seq squared, shows up over here under functions in the global environment. So now let's take this, what we learned from this simple example, and let's apply it to a netcdf processing function. Throughout these tutorials, we have loaded in the Willow Creek weather data set, and it's a little bit clunky, it's a little bit cumbersome. So let's create a function where what we can do is we can kind of wrap everything that we normally do with the loading in of a Willow Creek weather data set, and let's functionalize it. Let's wrap it inside of a function. Because ultimately, the only thing we really want outside of a function of this entire thing is we just want the resulting data frame. That's it. That's what we're getting at. We load in the Willow Creek data set, and then we have all of this info, we load in all of the variables, and then we convert it to a data frame, right? That's all we care about is the data frame. So we're going to create a function called read.wcr. The function's only argument is going to be fname, and that's just the file name. That's it. And so what we're going to do here is we are going to just, everything that we normally do within the function, we're going to provide here, and the only other thing that we're going to do is we're going to have to do a little bit of parsing here. So we have a couple different things going on. So the first thing is we're going to open up our fname right here, just like we provided it. And then all that we're going to do after that, this is just a couple of extra things going on here. This is how we create, we separate out basically what the data file is, what year the data is, and then we can create a date sequence from that. So it's just a little bit of extra info going on there where we create this data.date, which we then plug in down here. And yeah, ultimately we're just loading in a netcdf file, but we're just going to create a function out of it to make this easy. So we're just going to return this data frame. So let's run this. Now we have a read.wcr function over here. And now we can say read.wcr, and the f name is going to be, for me, it's in my datasets folder. And it's going to be, let's just load 2010. And boom, there's our data frame. So if we can actually save this, right? So we can say df equals, copy this right here. And because we're returning the data frame, we can store it as df, and df is right here. Boom. Here's our data frame. So, very quick, very easy. We can easily throw a loop around this. So we can use this function in a loop to load all of the data frames, or sorry, all of the data files. So if we have a sequence of years, we can basically say we want to, for y in the sequence of years, open up each year, which is y. If y is not, if y is not equal to the first year of the sequence, row bind them together. So just basically just append 2011 onto 2010 and 2012 onto 2011. Otherwise, if it is the first year in the sequence, we need to actually create the temporary data frame to be able to concatenate all these together. So let's just run this. And again, this is my string. This is where I store my data. It'll be different for you. Run this, and then now we have Willow Creek data frame, which is 3 times longer than df or temdf, and that is because we have all 3 years of data loaded in. So that is exactly, I go into more detail about what's going on. I kind of describe it all here, but that's what's going on. And that's how functions work. You can create your function to do whatever you want. Just remember, whenever you create a function, you just need to name it, and you declare that it's a function, and then you give it its arguments, and then everything that the function's doing goes within curly brackets the same way for loops. So we created this really cool function. Let's say that we wanted to share this. We wanted to share it with a colleague or somebody who was going to be using this function besides us, or even if we're just creating it for ourselves in the future. We can use R Markdown. Now, R Markdown is how I built this entire book. And basically, it's a combination of, it's a really nice feature that RStudio has, where it combines R code with HTML and allows you to create really nice looking pages like this, where we have different text and then different code strings, all of that good stuff. Now, if we wanted to convert this or some of this code into or just code in general into R Markdown, the first thing we're going to do is, instead of creating a new R script, we're going to come down here and click New R Markdown. Here's what's going to pop up, and we'll just call this Test Markdown. I'm the author, and then let's choose PDF as the output instead of HTML. So here we are. This is just some metadata for the PDF document. It kind of tells you what's going on. If you can type anything that you type, unlike an R document, like an R script, whenever you type any text, it is not R code. R code can only occur inside sections like this. So sections like this, we don't need, this is telling R Markdown that this is this right here is our code. Everything within these 3 backticks, curly bracket R, and these 3 backticks are going to be our code. Same with this. Now, the only difference between these 2 lines is that this cars is the name of this block of R code. So it's R code, but the name of this block is cars. And then this is R code, but the name of the block is pressure. Now, after the comma, echo equals false, does that mean? That means that we are not going to share that we are executing this code in the final document. Let's get rid of pressure. There again, this is just the name of the section. Let's get rid of cars. These are just naming the section. We do not need them. Let's say we're all done. We're ready to publish this R Markdown. So to do that, all we do is we click knit. And it's going to knit this R Markdown, and I'm just going to save it in my downloads folder as test. And what's going to happen is it'll execute. Notice you're in your R Markdown tab now. You're not in console like we normally are. This is a totally separate thing going on in R Markdown. And then when it's done, it's going to publish this R Markdown. So this is everything that we did. Here's our code right here. There's our code. It shows up and it executes the code. It shows us the result of that code. And then we have these plots right here. And because we had echo equals false, you will not see plot pressure within the document. Of course you don't, but it's still executing that code behind the curtain. That's why you see this plot. So this is plotting pressure, which is a default R data set. Same with cars. Cars is a default R data set. We don't have to load those in. So you can add whatever you want in here. You can just type gibberish. It doesn't have, you can just put whatever you want. But again, now the pound signs in our Markdown, instead of nulling out that section of code, it's actually serving a use as the title. So this is going to be a title. This would be a subtitle. This would be a subtitle, subtitle, all within here. And then we can still use within these coding sections, which are defined, which are started and ended by the backticks. Started by the backticks, 3 backticks, and curly bracket R and curly bracket. Ended by 3 backticks. This works like normal R code. So now if we knit this again, now we have our title, our subtitle, our subtitle, our gibberish right there. And then we have this works like normal R code. There's our summary, and everything else is the same. So that's how our Markdown works. We could paste whatever we wanted to. Let's say that we wanted to paste in, our code in here. And then we wanted to say, give us a summary of df. Okay, what's going on? It can't open that file. So it's probably because it doesn't know where it is. There we go. Now here's our function. Here's our summary of our data frame that we read in right here. And then there's just that other plot. Again, started here, 3 backticks, curly bracket R and curly bracket, and ended with 3 backticks. You also notice that the coloring is different. Now you can customize the heck out of these. I mean, you can bold and bolden, you can italicize, you can change, you can add bullet points, tables. There's so much you can do, but this is a really good base for now. And now what we can do is, since we knit this up, if I go over here and I go to my downloads folder, and I find my R Markdown file, notice that it's not .r. It is .rmd for our markdown, and then we have our PDF that we actually knit. So if I double click that, it's just going to work like a normal PDF. That's it. It's a PDF file. So that is what's awesome about R Markdown. It's so easy to do this. So, and I kind of run through all of that here. So for the assignment, what you're going to do is you're going to create a function that extracts and plots a spatial data set given a time range. So basically what I'd like you to do is take some of the code that you wrote previously in the remote data extraction, create a function that extracts and plots a spatial data set given a time range. So basically what you're going to be doing is your argument is going to be time. So you're going to be able to change the time. So you can choose a date as your time, and that can be your argument. So you're going to want to choose an online data set, create a function that extracts the data given a time range, creates a data frame, and plots the data set. It doesn't necessarily have to be a time range. It can also just be a specific time. That's fine as well. And then create an R Markdown PDF that details how that function actually works. Include an example of the function working and plot the given data set in the R Markdown file, and then just submit the PDF to Canvas.